I would like to welcome to the stage Varsha Rammohan, who's going to talk about AI-driven observability. Now, you might realize that that is not exactly what the program says. So she is on theme with what we were aiming to achieve, but our previous speaker fell through at the last moment. So Varsha, gratefully, was willing to step in, and she is going to share her presentation. She is knowledgeable and very prepared. She is, even though she scrambled at the last minute at our request. So we are grateful that she is here. I will let you further introduce yourself. Thank you so much for being here.
Yeah. Thank you, Julie. Yeah. Hi, all. Welcome to the session on From Signals to Action, Transforming Digital Experience with AI-Driven Observability. Just a quick introduction. I'm Varsha Rammohan, and I'm a lead product enterprise evangelist at ManageEngine. So to give you a quick introduction of what ManageEngine does, so ManageEngine is a privately held company which has been profitable since inception, and we've been in the industry for 20 plus years now. We provide 60 plus IT products that help you manage all of your IT, like starting from endpoint management to security management to full stack observability and a lot more. And we have 6,000 plus employees across the globe, and we operate across 190 plus countries, and we have 30 plus offices globally. And we also have our own data centers, which are located across multiple regions. This is because we put our data privacy first, customers' data privacy first. So we have our data centers located across US, Canada, Mexico, China, India, you name it, we have it. And we are still expanding. So to give you a quick brief of what ManageEngine does, so ManageEngine provides solutions for all of your IT needs. So we provide solutions that are hosted both on-premise, cloud, as well as for MSPs. So the solutions that we provide range from unified service management, identity and access management, IT operations management, data analytics, unified endpoint management, low-code app development, and a lot more. So today, particularly, we are going to be focusing on the full stack observability suite of products. So
AI,
in
AI,
the last
AI,
2 days,
AI,
I think this is something that you guys have been hearing throughout, right? And mind you, this clip is more than 2 years old, and this still stands true, right? So if you think, is this session going to be any different? I'm going to say yes, but no. I'm also going to be talking about AI. So in the next 30 minutes or 45 minutes, how much ever I can cramp in between, I'll teach you how you can save your money and time, your sanity by consolidating your tools, and how you can do all of these simultaneously while leveraging AI and delivering seamless digital experiences. Now, what we currently have is a web of interconnected systems, right? So when you say digital experience, so when you go to a website, it's not just the website that you're accessing. There are a lot of interconnected components that are right behind it, right? So you have your user interface that consists of your web, mobile, and single page applications. And then you have your backend API and microservices behind it. And then you have the databases, which are your RDBMS, vector stores, and so on. And then now you have AI or GenAI systems that are interconnected to it, which includes your LLMs, RAG pipelines, and a lot more. And then you have your infrastructure, which consists of your cloud, GPUs, containers, edge that powers everything. Now, all of these generate a lot of data, right? It's a lot of data. It's logs, metrics, traces, API latency. Now you'll also have to bring in AI into the picture, which means GPU, model drift, user sessions, token usage, and a lot more. So all of these systems together generate an explosion of signals. Now, what do you do along with all of this data? So because you have all of this data, you need clarity. But then the clarity now is less than ever. Because if you see, most of the machines tend to generate systems that we use, at least enterprises, what they use, they generate petabytes of data every single day. And almost 73% of the organizations experience outages due to ignored alerts from these data. And the time to resolve all of these issues takes more than an hour, which is a very, very long mean time to diagnose and resolve an issue, right? Now, the challenge isn't just collecting telemetry. It's basically making sense of it, because only if you make sense of data will you be able to do something meaningful with it, right? Even if you're leveraging AI, you still need to make sense of your data. Now, the problem most enterprises face is that they have too many tools and they provide too little context. Say, for example, you have multiple teams in your organization, right? You have your SRE team. Now, your SRE team might be able to see what the users interact with on an everyday basis, but they might not have any visibility into why your website is actually slow. On the other hand, your application or development team might have insights into the error rates, the response times, as well as your background transactions, but they may not be able to see the network congestion or the infrastructure load. Now, your infrastructure and the network team might have visibility into the network errors, bandwidth, and server health, but they might not have insight into the link between your server health and your service quality. At the same time, if you take a look at your security team, they might be able to see your log events, anomalies, threats, etc., but they cannot correlate them unless and until they have complete view into your application and your infrastructure. So what if your team could see everything, right from your applications, infrastructure, network, security, all in a single correlated view? This is exactly what ManageEngine offers. So what it does is that it helps collect data across all of your hidden layers, and it will help you make sense of it. Now, how exactly do you unify telemetry, right? Because you have all of these disconnected systems. You have your applications, infrastructures, network, security, storage, and a lot more. So you would need to make sense of all of this telemetry. Now, for you to be able to make sense of it, you would need to standardize and streamline all the data that's coming in. That's exactly why we use AI to do that. So what it does is that it correlates all the incidents, the AIOps, the application monitoring data, the SIEM solutions. It populates all the data and it makes sense of it. Now, to give you a glimpse of our AI strategy, for us, we believe that using AI without any context will not lead to any meaningful result. So we have built a platform in such a way that each and every layer offers complete context and you'll get operational insights. So our first layer is a data platform, which is our unified data platform, which consists of all the data that you can gather, be it structured data, unstructured data, your vector DB data, logs, metrics, events, traces, etc. So everything that you can gather comes under the data platform layer. Now, on top of the data platform layer, we have the LLMs. Now, the LLMs could be the large language models, it could be the small contextual models that you have, the context-aware SLMs or MLMs or anything that you have, which would help you generate the context. That's our second layer. Now, on top of this, we have the knowledge layer, which is basically Zia Search. Again, Zia is our in-house AI tool that we use it across the organization. So it's completely inbuilt and it's not dependent upon any third party. So the third layer is knowledge using Zia Search, which helps you get all of your RAG pipelines, your knowledge graphs, semantic data, your lexical data, and so on. And then the next layer is your context layer, right? So this particular layer will help you get context across your anomalies, your behaviors, any predictions, recommendations, etc. Now, because without any context, you wouldn't be able to make sense of what's exactly happening across your complex IT infrastructure, right? Now, the fifth layer is your conversational AI. Now, when I speak to most organizations and when I talk about AIOps, the first thing that they talk about is the chatbots. But if you look at the layer, the chatbot is the fifth layer. So it's not just the only area wherein the AI can help you. But we do have a chatbot that will help you have guided conversations. You can have using natural language programs. It will be able to give you a summary of all the incidents that has happened, and it will help you generate dashboards on fly and so on. And the last layer, the topmost layer that we have is our agent. So these agentic workflows will help you with the orchestration and all the other parts of it. So this, in gist, is a contextual AI strategy. So now I'd like to start this entire thing with a use case, and I'll just walk you through on how full stack observability driven by AI would actually help you deliver the best possible digital experience to end users. So say for example, you're using a retail platform and that particular retail platform goes down. So what's the usual process, right? The usual process is you visit a website, you go to the login page, and then you select the product, then you add it to the cart, and then you make the payment. Now there are points of failures, right? Say for example, when you're in the login page, you have a failure of 15 seconds. And then when you're adding the product to the cart, you have a failure again. So you will need to understand where exactly your users are experiencing their issues. This is exactly what full stack observability offers. Because the view that we have is two different things. The first thing is you'll be able to see the problem. The problem is users cannot complete payments, the page is extremely slow, and there are a spike in complaints. What your IT team might be able to see is that your application team might think, oh, my app looks totally fine. And the infra team might think your servers are extremely healthy. And your network team might think, okay, there is no problem from my end. Everything is okay. I am not the problem. But then, unless and until you have the complete context and visibility across all of these teams, you'll never be able to pinpoint the actual root cause of the issue. Now, for you to be able to do that, you would actually need to understand what the users are experiencing, right? So you would need to understand what the users are experiencing across geographies. Now, that's just a colorful map. But yeah, say for example, you're accessing an application from here, say Boston, and but a person out there in Michigan is unable to access the same application. You would need to understand if the application is behaving differently across geographies, or if it's across devices or browsers or ISPs and so on. So you also need to understand what's exactly causing the issue, right? Say for example, we have something called waterfall analysis, which will help you understand where exactly the issue lies, whether it's the page load time, whether it's a third-party dependency, whether it's an API call, and so on. Now, once you have visibility into that, you also need to understand the entire user journey. So where exactly are your users dropping off? So where exactly are they experiencing frustrations? Is it when they're adding the product to the cart? Or is it when they are making a payment? So what exactly is happening? Next thing that you need to understand is the business flow. So you will need to understand when you're replaying the particular session, what's happening behind the actions. So where are the errors that are happening? Where is the unexpected drop-off happening, and a lot more. So once you have a clear view of what's happening in the front end, the next thing that you need to have a clear view is what's happening in the back end. So this is how your back end looks like, right? I know it's a lot of transaction. It's like app layer, and you have your underlying components, and etc. So it's not as easy as how it looks in the front end, right? So when you're accessing your website in the back end, you have your DNS resolution, TLS handshake, and HTTPS requests that are going in the background. And then when you're viewing your items, you have a record retrieval, item lookup, and stock verification going in the background. And when you're submitting the payment, there is a third-party API call that's happening. So you would need to understand the entire transaction that's happening and what's exactly causing the issue. So it could be the database call that's causing the issue, it could be the API latency that could be the issue, or it would not even be the application, it could just be the network. So for you to be able to understand all of this, you would need deep insights into what's happening within your application. So for you to be able to understand this, we have something called application performance monitoring, which will help you get deep code level visibility into the back end of your applications. So you'll be able to see the entire transactions as well as the trees within that particular transaction. Say for example, if a particular database call is causing the issue, because most of us have microservices environment right now, right? So you have like multiple components, services that are calling out to each other, and then maybe a failure in one particular component could cause the entire chain to break. So that could be the issue. So once you'll be able to pinpoint to this particular issue, you'll be able to automate as well as resolve it. And we have something called the service map, which will help you understand all the dependencies that are present, and it will help you drill down to the root cause of the issue and will help you understand what's exactly impacting the particular thing. Now that we have insight into the application side of things, I'll quickly go on the network side. So now what you would actually need is, once the application team is like okay with the visibility that they've gotten, you would need to have complete visibility into how your network is behaving, right? So sometimes it could be just one congested LAN link or WAN link or one high latency path that's actually causing the issue. But unless and until you have visibility into your wide distributed network, you might never know. So this is exactly why we have hop by hop analysis, so which will help you understand exactly at which point your issue is happening. Because when your network packets are flowing in and out, right? So you'll need to understand where exactly the WAN latency issue is happening, why it is happening, at which duration it's happening, and what's exactly causing the issue. So you'll be able to drill down to the root cause of the particular network issue. Now that you have complete visibility into the hop by hop analysis, you also need to understand things from a security angle, right? Sometimes you have abnormal traffic. Say for example, your application is usually receives a traffic of say 2K visits a day, but now it's receiving a traffic of say 5K visits a day, and that's very abnormal, right? Unless and until it's intended. So you will need to understand the abnormal traffic behavior patterns that are coming into your network, because sometimes all of these latent traffic that goes unnoticed might turn out to be an actual attack. So you'd also need to make informed decisions regarding the resource allocation for your network. Yeah. So to be able to spot all of these abnormal traffic, the first thing you need to do is to detect. Now, detection involves like understanding all of these unusual traffic, right? So is this an unknown destination? Is this an abnormal communication path, etc.? Now, once you've detected the issue, the next thing is context. So again, this is where the AI layer comes in. So what our tool does is that it will help you understand the baseline of a particular asset. Now, this application is supposed to be receiving only 2K of traffic, 2K visits a day, but it's now receiving 5K. Now, this is beyond the baseline. So it will map you to the pattern. So it will identify the abnormal pattern, and by using the Metri attack framework, and it will score the pattern based on the severity. So once you get that particular context, you'll be able to respond faster. So you'll be able to see the previous offenders and the victims, if any, and in case it's a new attack, you'll also be able to see if this is a new pattern that's forming in your infrastructure, and then you'll also be able to reduce the investigation time by a huge extent, and you'll also be able to act before your users experience any major issues. So this is the framework that we have. So it will basically use anomaly detection based on ML. So it will understand any deviation in your traffic patterns, unusual protocol behaviors, and any potential policy violations. Now we are going to see how everything is connected, right? We spoke about digital experience, we spoke about applications, we spoke about network. So how was it all connected across the infrastructure? So we have something called an organization map, which will help you view all the assets within a single view. So you'll be able to understand and map your services across your applications, infrastructure, network, and even external payment systems in real time. So this will give you the blast radius of any attack, so that you'll be able to understand if, say for example, there is a problem with the database tier, and that particular database, because of the problem in that particular database tier, all the other dependent services are completely affected. So you'll be able to pinpoint that particular issue and you'll be able to resolve it. Now that we have a complete visualization of things, how do you correlate them, right? Because what most IT teams struggle is with the barrage of alerts. So say for example, if your server is down, you receive an alert. If your API latency is up, you receive an alert. If your database is performing poorly or if your query is slow, you receive an alert. But what do you do with all of these alerts unless and until you have actual context to them? That's exactly where our AI-driven event correlation helps. So what it basically does is that it correlates events across your infrastructure. So it helps you understand, hey, okay, there is a problem with the server, the application, the database, and the network. Now, are all of these alerts actually related to each other? So what it will tell you is it will give you one single contextual alert. So it will collect across your infrastructure, connect all the components using the organization map, and it will detect the issue and it will give you a single contextual alerts. So to give you a brief of how this entire thing works, so what it basically does is that it does smart analysis, which means that it targets qualified impactful events, because you don't need to receive an alert for every single event that's present in your infrastructure. So it's enough only if you receive an alert for events that actually matter, right? So only if you receive an alerts for events that actually matter, you'll be able to prioritize and get them resolved. So that's exactly what smart analysis does. And then we have dynamic detection. So the dynamic detection here can be divided into two. So one is causal AI and the other one is domain aware. So the domain aware is something, it means that it has understood the pattern before and it's like predicting in a very like known environment. Of course, if the environment is unknown or if the pattern itself is extremely new, then it uses causal AI in order to understand the previous understand the current framework, as well as analyze and understand where exactly this particular issue is coming from. So dynamic detection actually helps you compare to the baseline values as well as detect anomalies and correlate them. Now, after all of this, you'll be able to like get one single contextual alert, which will help you like speed up your fixes, your SLAs, as well as boost your resilience. Now that we have our alerts in place, the next thing that you need to have is predictive capability, right? You would need to understand which action that you need to prioritize. Now, say for example, you have your CPU and it's at 70% today. Now, say it's, for example, it's going to reach 90% in like 3-4 days. Now, what our forecasting will actually do is that it will give you a prediction, say, hey, your CPU is going to reach 90% limit in like the next 3 days. So these are the suggestions that you can take, and these are our recommendations. And you can basically log in to ticket into your help desk using Ansible, or you can execute workflows, or you can just like ping your services team or run playbooks and do whatever. So you'll be able to understand and predict the resource utilization of your infrastructure. Now that we have the alerts in place, which is one single contextual alerts as well as the prediction in place, the next thing that we have is automation, right? So you actually need to automate and remediate these issues. So this particular automation will basically help you understand, and it will like help you avoid manual work. Say for example, you have an automation cycle in place wherein if the payment response time exceeds 3 seconds, then you basically either need to like scale your database resources, or restart your impacted services, or reroute the traffic onto the critical jobs, and a lot more. Now what it will basically do is that, since we have a tight integration with your service displays as well, it could be Jira, ServiceNow, or any other third-party tool. So what it will basically do is that it will notify your IT team, it will log in the resolution, log in the incident, as well as it will help you track the resolution. It will help you understand if your ticket has been resolved and if your CIs are properly synced. Now that we have seen how the entire infrastructure works, how we can automate things, and how we can get contextual alerts and remediate using AI, what organizations now need is complete visibility into how AI systems operate. Now, up till now, we was talking about observability into your infrastructure itself, which is your network, applications, storage, firewalls, etc., etc. But to be able to completely use AI as well as to be able to leverage most of it, you would also need to understand how it is working in an environment, because now most of the components which are basically your AI copilots, fraud engines, and automation workflows, all of these introduce new operational dependencies, and if these are not tagged, or if you don't have visibility into them, that might actually bring up problems in the future. So this is basically what we're going to be speaking about. So we saw the applications, the infrastructure, networks, and databases. And now we have a very new layer added to it, which is your AI services, copilots, or agents. Now from all of these, you have your unified operations intelligence layer, which will correlate insights from all of this, as well as it will give you and tell you what to do. So when it comes to observability for AI systems, we support a wide range of LLMs. It could be Claude, it could be Gemini, it could be Microsoft Copilot, it could be OpenAI, anything. So what you'll be able to do is that you'll be able to track the performance of your LLMs, including your, you'll be able to spot your model drifts, you'll be able to see any breakage in terms of your LLMs, any kind of issues, pain points, any slow or failed LLM response chains. You'll be able to get a complete insight into all of these things. Now, in case there are any anomalies across your LLM systems, you'll also be able to quickly pinpoint and spot them, just like how we discussed before. And you'll also be able to ensure complete LLM reliability. Now, most of the organizations today, they don't just have one LLM in place, right? They have multiple LLMs. They have a mix of public LLMs and private LLMs for security and context purpose, and even just the environment purpose. So this could be like multiple LLMs, and because of this hybrid model, what you need is like complete context aware into what your hybrid LLM is actually doing. So you need to understand any kind of like alarms that it's triggering, like you need hybrid visibility, right? Like say for example, if you have insight just into your public LLMs and not into your private ones, then you might be missing out on the entire context itself. So what we do is that we provide context-aware AIOps with hybrid LLM integration. So this will like help you summarize your alerts, surface any anomalies, and accelerate your root cause detection. I don't know why it's not playing, but yeah. So say for example, you have multiple systems, right? That's what we spoke about, disconnected systems. You have your tools for observability, your tools for SIEM, tools for endpoint management, your data platform layer, and a lot more. Now that you have your AI systems also in place, what we have is an MCP integration. Now, what our remote MCP server does is that it acts as a bridge between your AI as well as the disconnected systems. So what it will basically do is that it will retrieve data from all of these systems and it will help you make sense of it. So say for example, your customers report delayed payments or failed mobile transactions, or say for example, your AI-powered fraud detection workflows are introducing an additional latency during traffic periods. Now what the MCP server will basically do is that it will collect all of this data and it will help you like summarize that information. So it will tell you like where exactly the particular problem is occurring, what exactly you need to do, and where exactly you need to like perform your activity. So this will help you accelerate troubleshooting to a large extent, and it will help you investigate incidents in a contextual manner, especially across disconnected systems. And it also like supports governed access using API key authentication as well as user level permissions. That way everything that you do is completely safe and secure. Now this is our product, it's called ManageEngine App Manager Nexus. So this completely gives you AI intelligence across every single layer. So the first layer that you have is the observability platform. So what it basically does is that it gives you the application insights, the server insights, your network, data flow insights, as well as security insights. Now, the application insights might involve like app-specific metrics, telemetry, code-level insights, user experience, geo-testing, and a lot more. And then you have the server insights, which could be your physical, virtual, cloud, cloud server, which might include your transaction analysis, performance metrics, and a lot more. And then you have your network insights, which could be your traffic pattern analysis that we spoke about earlier, as well as your configuration compliance, forecasting, scaling, and a lot more. And then you have your data flow insights, so which could be your east-west traffic, your structured and unstructured data across your LLMs, and so on. And then finally, we have security, which could be your domain security, your infrastructure security, etc. So all of these combined together, it'll, with the help of Zia, which is our internal AI engine, it'll like help you understand the entire context. Like it'll help you identify anomalies, your consumption analytics, correlate across cross layers, forecast resources, as well as like dig down to the root cause of issues and remediate the workflows very quickly. So this is what our observability platform has achieved in the last 1 year. So we have been able to like successfully prevent 75 million plus outages because we have a very wide range of operations. We operate across multiple countries globally, and this is a global stack. And then there has been a 50% surge in adoption of our GenAI capabilities, and we've been able to observe 50 billion metrics, and we've been able to capture 1.8 billion errors, and we've been able to ingest 2.8 petabytes of data. So with all of these, we've been able to like prevent 318 million hours of downtime, as well as 14.7 million incidents have been detected early. So these are some of the like the exciting stats, I would say, that we have with respect to our tool. So our tool kind of operates across on-prem as well as cloud. So Op Manager Nexus is available both in on-prem as well as cloud. So now to give you a quick brief of what we spoke about. So we spoke about how fragmentation, like having like teams that do not have complete visibility or contextual visibility into what you provide is a problem. And we also spoke about how organizations or enterprise generate millions of data, and without any context or open telemetry streamlining, they do not have, they can't make sense of it. And we also spoke about how full stack observability helps connect user experience with what's happening across your applications, infrastructure, network, and security. And we also spoke about how AI is not just an good to use word, but it needs to be an inbuilt component across your FSO tool, which should actually help you like correlate your issues, make smarter decisions, as well as automate any responses. So just to give you a brief of what ManageEngine does. So ManageEngine is also compliant with international security and privacy standards. We take our security and privacy policy very, very seriously. And we've also been recognized by leading analyst firms across the globe, which includes Gartner, Forrester, IDC, ISG, GigaOM, Omdia, and a lot more. So thank you so much for attending this session. So in case you have any queries, I'm there in the booth, or we can talk now. Thank you.
Thank you very much.